Hi, this is Saranya from the Department of Artificial Intelligence and Data Science. Today I am going to take the topic error control in data link layer from computer networks. So at first, error control in data link layer consists of two types of error control. One is the error detection and the another one is error correction. At first we will see what is error control. So error control is basically process in data link layer for detecting or identifying and retransmitting the data frames that might be lost or corrupted during the transmission. Error detection techniques consist of three types of error detection techniques. So first one is parity check, second one is checksum, third one is cyclic redundancy check, that is CRC. At first we will see what is a parity check. In this parity check, there are two types of parity check. One is the single parity check and the another one is two-dimensional parity check. Single parity check. A single bit is appended to the end of each frame. The bit is 1 if the data portion consists of odd number of ones. The parity bit is 0 that we are going to append at the last portion of the data frame if it consists of the even number of ones. So let us discuss this single parity bit with an example. In this original data unit, we consist of 1, 0, 0, 1, 0, 0, 1. This is my original data unit. So in this, let us count the number of ones present in this original data unit. That is 1, 2, 3. So we are having totally odd number of ones present in this original data unit. So I am appending the last portion of the data frame with the parity bit 1. So consider if I am not having this last portion as 1. If I am having this last portion as 0, this last portion as 0, then I will be having the total number of ones in this original data unit as even. So it will be the original data portion will consist of even number of ones. So I need to append the parity bit 0 at the last portion of the data frame. And then I need to transmit the data to the receiver end. And then next we are going to see the topic two-dimensional parity check. In the two-dimensional parity check, we are going to do the same that we did in the single parity check, but we are going to check the parities across the rows and the columns. Consider a matrix. In the matrix, it will consist the number of rows and the columns. We are going to check the parity row-wise and also along column-wise. We are going to check the parities. So this is the example for the two-dimensional parity check. So here we are having the parity bits we are going to check the parity bits row-wise and then also in column-wise. Here these are the number of data frames that we are having in this example. So in the first data frame 110011, this is the data that I am having. So count the number of ones present in this data frame. The number of ones will be 5. So if I am having 5 ones, this is the odd parity. So I am appending the last field with the parity bit 1. Consider the second frame. Here I am having the number of ones, 5 ones I am having. So the number of ones in the second frame is odd. So I am adding the last field with the parity bit 1. Likewise, in the next row, I am having the number of ones, 4. So it is an even parity. So I am adding 0 as the parity bit here. Considering the fourth row, here I am having the number of ones, 3. So odd number of ones, so I am adding the parity bit as 1. So we have seen the parity along rows. Now we are going to see the columns, column-wise parity check now. In the first column we are having 2 ones, even parity. So I have appended 0 at the last field. And then in the second column I am having odd number of ones. So it is a odd parity. So I am appending number 1 at as the parity. And then in the third column I am having even number of ones. So the parity bit is 0. At the fourth column there are odd number of ones. So the parity bit I have appended is 1. And the fifth column I am having even parity. So the parity bit that I have appended is 0. And in the sixth column the number of ones is 1. So odd parity, so I have appended the number 1, parity bit as 1. And in the last column, I am having even number of ones. So I have appended the parity bit as 0. So in the two-dimensional parity bit, we need to check the parities through row wise as well as through column wise. Next, we are going to see the checksum. This is a block code method where the checksum is created based on the data values in the data blocks to be transmitted using some algorithm and appended to the data. When the receiver gets this data, a new checksum is calculated and compared with the existing checksum. A non-match or error, a non-match or mismatch in the data frame at the receiver side indicates that there is an error in the received data frame. So let us see the example of checksum. For error detection by checksum, data is divided into fixed number of frames or segments. At the sender end, it will do the arithmetic addition for the number of data segments, and then it will get the sum. It will complement the sum to get the checksum for the particular data frames. That checksum is further appended with the original data frames and then it is sent to the receiver end. At the receiver end, the received data frames are again calculated with the help of the arithmetic addition to get the sum. This sum is now added to the checksum that we got from the sender side, and then again we took the ones complement for the result. If the result consists of 0, then it is considered as the error-free message, or the message sent from the sender side is the correct what we have received at the received end. Otherwise, if it is not a 0 at the receiver end after ones complement of the checksum, then it is considered as the mismatch, or it is not a correct data that what the sender sent from their end. Next, we are going to see the example for the checksum. So consider the 4 frames, frame 1, frame 2, frame 3 and frame 4. In the frame 1 we are having 1100, 1100. Frame 2 we are having 1010, 1010. So we are doing the arithmetic addition. 000, 011, 101, 110, carries 1. So 1 here, 011, 101, 1 with 1 we will get 10. So when we keeping this 8 bits and then this 1 is just carried around here, and then this 1 is again added with this portion. So 011, 1, 1, 0, 111, 0. Now the third frame is added with this, and then again the same process is continued up to the fourth frame. Now we got the sum as 00101100. Now we need to take the ones complement for this sum to get the checksum. The checksum value is 110, 100, 11. Now this checksum is appended with the original data frame and then it is sent to the receiver side. At the receiver side, further the arithmetic addition is performed for the frame 1, frame 2, frame 3 and then frame 4, and then we got the same sum value here. This sum is again added with the checksum, that is appended and sent from the sender side. So the sum is added with the checksum and then we got the result as 8 bits consists of ones. We need to take the ones complement for this result. If it is 0, then the frames are accepted and then there is no mismatch between the frames received at the receiver side. If it is not 0, then it is considered that there is a mismatch exists between the frames sent from the sender side and received at the receiver end. Next, we are going to see about cyclic redundancy check (CRC). Here the original data portion is given. The data portion is performed, a long binary division is performed between the original data portion and the given divisor. Before going to perform the original data, going to perform the long binary division, we need to append the original message with the L minus 1 bits. What is that L? The length of the divisor is considered as the L here. The length of the divisor is considered as L here. So L minus 1. For example, the divisor length is 4. 4 minus 1, 3 bits are appended at the end of the original message. Then we need to perform the binary division operation. The remainder of this division is considered as the CRC. So the XOR table is given here to make you to understand the binary division. So the XOR between 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1, 0. So, okay. And then next, at the receiver side, sender side, we are having the original data as 1, 0, 0, 1, 0, 0. Then how these three zeros are appended? That means I need to append the L minus 1 bits at the end of the original data. So here the length of the divisor is 4. So 4 minus 1, 3 zeros are appended here. And the long binary division is performed. And then we get the remainder as 0, 0, 1. So this is considered as the CRC. This CRC is added with the original message. The original message is 100, 100, 000. So with that the CRC is added, and then this added portion is transmitted to the receiver side. At the receiver side, this is further the transmitted data is further performed long binary division with the divisor. And then at the receiver end, after doing the long binary division for the received data portion, if we get the 0 bits at the receiver end as a reminder, then the data is accepted and it is considered that there is no error found between the data frames sent from the sender side and what the data that is received from the sender side at the receiver end. The frames are error free. If there is no zeros that we have received as a reminder at the receiver end, then it will consider that there is a mismatch or error exists between the data frames sent from the sender side to the receiver side. Thank you.